Well, friends of mathematics, we're talking about calculus section 1.2, and I want to talk about how to make a formula for an exponential by using a horizontal shift. And I guess we should probably talk about this thing from section 1.3, that if I have f of x plus h, or f of x minus h, what we have here is a left shift of h units. And then for f of x minus h, we have a right shift of h units. And that's going to be important to us. And what I need us to contemplate to start out is, suppose I gave us some exponential function, and I'm going to tell us a couple things about it. I'm going to let us know that we have certainly an exponential growth here. And I'm going to tell us that, say, we are going to go through the point 0, 7, and I'm going to let you know that the growth factor is equal to 1.6, okay? So 60% growth. Let's have an x-axis, let's have a y-axis, and making the equation for this purple function should be done, yeah? We should be able to say that this is f of x is equal to 7 times 1.6 raised to the x power, yeah? Not a great stretch of the imagination. What I'd like us to contemplate now, though, is this orange function. Suppose instead of going through the point 0, 7, I want our function to go through the point 13, 7. And I want it to look exactly like this other function. And so I moved it over, and I'm just going to trace it now orange. All right, my tracing is not as great as it could be. And then we'll see if I can move it back. And I have, yeah? So really, what I want us to think about is I've taken the point 0, 7, and I've shifted this purple curve to the right 13 units. So what will we do? We can certainly say that this orange curve is f of x minus 13, because that's the way that we indicate a right shift of h units. But what does that actually look like in the context of the formula? Well, it would be 7 times 1.6, and instead of x, we're going to have the quantity x minus 13. Now, what's fantastic about this formula right here is, and let's call it g of x for just this orange function. The thing is, when I put 13 in for g, a 7 better come out. And so let's take a look. G of 13 is equal to 7 times 1.6 raised to the 13 minus 13. We'll have 7 times 1.6 raised to the 0. And that just gives us 7 times 1, which was exactly what we wanted. Yeah. Let's do it again, this time employing the technique that we used previously to talk about how to make a growth factor, okay? So I'm going to clear everything. I'm going to make a very quick graph for us with 2 points. And I'm going to pick one point over here. How about to the left? Let's use the point -2, 10. And let's have, and I'm going to actually make sure that that is not an upshifted or downshifted graph. So it's just a regular exponential. And let's have another point over here. Let's use this point, and let's say that this is, if that's 2, let's say 7, 1. Now, the first thing that we're going to do is we're going to get our growth factor. And so let's do that. So we're going to have b is equal to y2 over y1 raised to the 1 over x2 minus x1. And let's just begin plugging in. We'll have 1 over 10 raised to the 1 over 7 minus a negative 2. And so we'll have 1/10 raised to the 1/9. So that's our growth factor for this red curve. And what I'd like to think about now is, suppose I wanted to make this curve here with the exact same growth factor, the exact same b value, but going through the point 0, 1. Well, the formula would be y is equal to 1 times 1/10 raised to the x over 9. But the green function isn't the one we want. What we want is to take that green thing and shift it to the right 7 units. And so one possible formula for this red curve between our 2 points is y is equal to 1 times 1/10. And instead of x over 9, we'll have x minus 7 over 9. And we're done. The other possible formula that we could use here, and this is certainly a valid formula for our function, the other possible formula would be using this point right here, and that point would be 0, 10. Exact same growth factor that we used previously. And so the formula for the blue would be y is equal to 10 times 1/10 raised to the x over 9. But I don't want the blue curve. I want the red one. And so I would have to go left 2 units. Well, how do I do that going from that blue curve to the red one? Well, I'm going to have everything that we had. Y is equal to 10 to the 1/10 power. But instead of having x, we have to have that left shift, x plus 2 over 9. So either of these formulas is going to give us full points on the exam, and it is highly superior than finding the initial value, which is when x is equal to 0, right? I mean, for the most part, I think the way that other videos talk about this, or they talk about the material, is they say find the initial value, and then you just have a b to the t. But I think it's slow and cumbersome. If I wanted to know the initial value, I could put 0 in for x into either of these. The initial value would be 0, 10 to the 1/10 raised to the 2/9 power. Or an alternate initial value, which is the exact same value, would be 0, 1 times 1/10 raised to the negative 7/9. And I know that you're saying, Paul, these things don't look remotely alike, do they? But I'll remind you, if we look over here, that's 10 times, and I'm going to write it like this, 1 over 10 to the 2/9. That'll be 10 to the first minus 2/9, and that'll give us 10 to the 7/9, yeah? Which is exactly what happens here. By having the negative, I have the reciprocal, so we'll have 10 to the 7/9. And we have the exact same result. No simplification is necessary at our fine institution. You can just leave it the way that we have it here, or like this, and both of those are going to be more than acceptable answers for our exams. As always, if you have any questions or concerns, be sure to send me an email.